That's a heavy graphics card, RTX 4090. I'm really excited. This is my first of the 40 series cards for mine. I've been kind of sleeping on them, and I just decided to go all out with the 4090, which seems to be the best of the current generation of 40 series cards, though we do have some supers coming out in just a moment. So plans for this video: one, I'm going to do a little bit of an overview of this card, compare it to the 3090 Founders Edition that I have, as well as we're going to do a deep dive into the power silliness that's been going on with this GPU, especially looking at it from a modding perspective, what I need to do to be safe using the power connector, which I didn't even realize has been tweaked on the 40 series GPUs. We'll go over that in just a little bit. And then finally, we're going to get it up on the test bench here, and we're going to do some early hash rates on a popular mining algorithm for this GPU. So let's get started. RTX 4090 Founders Edition is absolutely beautiful. You can see it right here. And not much has changed on it aside from the power connector on the top is in a little bit of a different place, and it's actually a different connector than what was used on the 30 series card. So I'm actually going to pull over. This is my RTX 3090 Founders Edition card. Beautiful GPU. You can see it right there. And I want to do just a comparison on these two cards. So the 4090 is definitely a little bit bigger, though not substantially so. Just a little bit bigger fan setup on it as well. But otherwise, they look pretty much the same. It's actually got a different finish, which I didn't realize, than on the 3090. It's a little bit of a lighter finish on the Founders Edition card of the 4090 here. But the big thing that I noticed is that power connector is actually in a different location on the top of the GPU. The 3090 has it angled, so the power cables will come out of the side, and then the 4090 has it coming straight off, which I think has been contributing to some of the issues that gamers have been having, because when they slot this card into their case, for example, the door or the window of the case is going to be right here, and that power connector is going to be coming right off the side, which sounds like has been causing some of the connectors to not be seated properly, and then it's pulling all this power, and there's been a revision to help out with all that, but we'll get into that in just a second here. But otherwise, it's not substantially larger than the 3090. I think it looks really nice. Founders Edition cards are absolutely beautiful, especially compared to some of the cards in the old days, some of the old Founders Edition cards. They've definitely figured out the cooling setup, NVIDIA, in some of these GPUs, Founders Editions now. So what do I want to talk about? I want to talk about this power connector. And just doing all of this kind of stuff safely in mining is really important to me, because I don't want to burn my house down. And I've covered it quite extensively, and I'm going to cover it again here. I've been diving into the specifications, which I'll throw up on the screen as I continue to talk about this power connector on the GPU. So on the 3090 and the 30 series cards that used the newer style power connector, they actually used what was called, is a 12-pin power connector. It's 12 pins, went over to 2 of the 8-pin adapters, and like that's just what it did. And it came off the side, so made sure that was really safely in there. And then the 40 series cards came out, and they took some of the technology and innovation around GPU power to the next phase, and that became the 16-pin 12-volt high-power connector. You have 16 pins on there, and 4 of those are dedicated to sense pins to make sure that it is pulling the right amount of power over the specified power supply and all of that. And so then you get what this GPU came with, the 4090 connector that goes from that 16-pin to 4 8-pins, as you can see there, which we'll get into more in a little bit as well. And so all of that sounds really great, but what happened is the margin of safety, because of the old PCIe 8-pin spec and 6-pin spec, and then this new 16-pin spec, the margin of safety became really, really small for what that connector and the GPU can call for power-wise, versus electrically what the pins and the wires that make up a cable that goes to a power supply actually could do under load. There's actually been a revision on the 40 series cards, which I had no idea. The PCIe spec has been changed so that it ensures really good contact with this 16-pin connector, of which 6 of those pins in there carry power. And so what was happening before is you would have the 6 pins connected in here, and then the sense pins as well, and the cable would be plugged in, right? Similar setup to this, plugged in, but then just because I'm a gamer and I have this thing in my case that I already have, now my connector is getting bent and twisted, even if I have the adapter or one of the new power supplies that have the 16-pin cable that goes right to the power supply, and would cause the connector to not seat properly. And so you would have one of those pins out of those 6 pins maybe not seated right, be able to carry the full load, and the rest of the power is dispersed amongst the other 5 pins, and they go over spec, and they heat up, and they cause the plastic housing to melt, or perhaps some burn marks on the cable or the GPU itself. And so what NVIDIA has now put on their GPUs is the latest revision of the PCIe spec, which is called the 12-volt 2x6 pin connector. So we've went from the 16-pin 12-volt high power connector to now it's a 16-pin connector that is called the 12-volt 2x6. And so the conductor pins are now longer to make sure they have full contact, and the sense pins, which are the ones that say, hey, I'm fully seated in there, you can call that much power, are shorter. So longer pins that carry power, shorter sense pins. In the end, what that means is it allows it to be fully seated inside the GPU as much as possible before it pulls 600 watts over this cable. Still, your margin of safety is so much smaller than it was before. And let's break that down electrically a little bit. And this is all the standards and the specs. I'll throw this stuff on the screen as I talk about it. Let's start with this connector. This is the 12-volt 2x6 pin connector. So 6 of the pins on this will carry power. And each pin has a rating. And they're each rated to do 9.2 amps. So now we got to do some math to figure out how much wattage this whole thing can do. So you take your 9.2 amps, you're going to times it by 6 because we have 6 pins that can each do 9.2 amps. And then you're going to times all of that by the 12-volt rail on the power supply. And what you're going to end up with is 662 watts that this cable can do electrically. That is what it is designed to do with how it's built. So remember that, 662 on a cable that will pull 600 watts. If the GPU asks for 600 watts, it will do that, leaving you 62 watts of headroom. Let's go back to the 8-pin. On a GPU that has an 8-pin, that will only ask for 150 watts over that 8-pin connector. That's what it is spec to do. It will never ask for more than 150 watts, and on a 6-pin, no more than 75 watts. So let's break down the 8-pin connector a little bit. That connector has 3 pins that carry power, and they're each rated for 8 amps. So then you do 8 times 3 times the 12-volt rail, and that cable can actually do 288 watts. Electrically, that is what it is designed to do, though it will only ever pull 150 watts because that's what the GPU is asking for, leaving you a headroom of almost double what that actual cable will carry under load from the GPU, compared to this new connector, which, what was it? 62 watts is the headroom. So here's why it's a little bit dangerous, and you got to be really careful with this stuff. Let's go back to our 16-pin connector. If one of those pins were to fail or not be seated properly, yet the cable itself and the GPU are still going to call for that 600 watts, it's going to disperse all of that power over the remaining 5 pins, and they're actually going to go above the amount of amperage that they're designed to do, thus resulting in overheating, burn marks, etc. Whereas when you have an 8-pin power connector, one of those pins could fail, and the other 2 pins could carry the excess load and disperse amongst those 2 because the margin of safety is so large, and it would just be totally fine, and you would probably never even know. So going back to this 4090, it calls 450 watts. That's its TDP. Yet, we're gonna get it on the bench here and see if I can get it to pull up to that 600 watts, whether I overclock it. And this is the Founders Edition cards. There's other GPUs from their board partners that you can overclock even further. And so you're really testing the limits of this cable. You can get it to do the 600 watts, giving you such a small margin of 62 watts. So let's get it up on the bench. We're gonna get it testing on some algorithms, and I'm gonna see how much power I can pull over this thing, and we'll measure it on the PCIe meter. Up and mining on Kawpow right now, and this is not really wired up. I don't think that safely. It's just for testing purposes, but I got a mess of splitters going to this GPU because my PCIe meter has 3 8-pins, yet I need to be able to do the 4 8-pins going into the 16-pin plus the 6-pin that's going into the riser on the bottom to be able to measure this all accurately through the PCIe meter, which I have hooked up right now. You can see it right now. Displaying 288 watts is being pulled in line from this GPU over to its power supply, which in the software is pretty accurate, about 10 watts off from what the monitor is reporting right now. But one of the things I wanted to take a look at is just what the power limits are for this GPU, and HiveOS will show you that. So it shows me that I guess the minimum down here is 150 watts, and then the TDP is 450, and then 600 watts should be the maximum I'm able to do over this graphics card. And again, right now, I'm mining absolutely the most efficient on the Kawpow algorithm that I've been able to tune this GPU with. By the way, we should pause here and just take a look how that compares over to some of the 30 series cards that I was testing. So looking at the efficiency, we're at 210 kilohash per watt. And if I go to the video I made just a little bit ago, it's kind of small, hard to see, but trust me here, the only GPU that was even close was the RTX 3070 coming at 201 kilohash per watt, but no other GPU is able to break that 200 mark. Yet here, this 4090 is just breezing by doing 210 kilohash per watt. And that's with the fans up pretty high. So I'm pulling more wattage than I even need to be on this graphics card. But anyway, that's mining at its most efficient settings. What I want to do now is see how much power I can get this to pull. Again, just to test if I can get it up to that 600 watts, even on this Founders Edition card. So what I'm going to start doing now, I already have the memory maxed out to 4,000. I'm going to see how much core I can give this GPU to see how much power it's now going to call for. Pushing up against 460 watts now on this GPU, and the way I've been able to do that is by keeping that memory offset of 4,000 and switching from a lock core over to a core offset of 240 with the power limit of 600 watts, but it doesn't seem to be able to want to do up to that 600 watts on this specific GPU. I don't know if it's firmware lock. I don't know if there's something I'm missing that I can do in HiveOS. It's not going to be efficient at all mining at that amount of wattage, but I kind of just wanted to see what I was going to be able to get with it. But I think that is it for this video. That is the RTX 4090. What's coming up is I'm going to do some hash rate testing on all the popular mining algorithms, get those out to you just to see what this GPU is made of. Like button, sub to the channel, take care of yourself, each other, and I'll see you in the next video.